Hello guys, welcome to this wonderful chemistry lesson. In today's wonderful chemistry lesson, we are going to revise the question on the board or on the whiteboard, which is coming from more concept and balancing chemical equation. All right, so I hope by the end of this lesson, you will be able to write balanced chemical equation and also answer some of the questions that come under more concept. So without further ado, let's go straight into this revision. All right, so here is the question. The question says, this is coming from science paper 2 revision. Question 4, magnesium reacts with dilute hydrochloric acid to form magnesium chloride and hydrogen gas. A, write a balanced chemical equation, include state symbols for the reaction of magnesium and dilute hydrochloric acid. Then B, calculate the mass of magnesium chloride formed when 6.0 grams of magnesium reacts with an excess of dilute hydrochloric acid. All right, so let's write this one. So let's go for solution. So this is 4A. So what they're asking us to do, guys, is to write a balanced chemical equation. Write a balanced chemical equation. So we need to understand what a chemical equation is. Okay, so a chemical equation is a short way of writing a chemical reaction using chemical symbols of elements found on the periodic table. So what am I saying? I'm saying a chemical equation is a short way of writing a chemical reaction using the chemical symbols of elements found on the periodic table and also using the chemical formula of compounds. So once you understand that definition, you will be able to go out there and be able to answer questions on balanced chemical equations. So let's do this one so that you see. So you are told to say magnesium reacts with dilute hydrochloric acid. So there is magnesium. So write a weight equation. You write it like magnesium then where they say reacts with, it means plus, you put plus. Then dilute hydrochloric acid. You write dilute hydrochloric acid, just write hydrochloric acid like this. Hydrochloric acid. Then next to this, they're saying to form. When they say to form, you put the arrow. Then what is being formed? Magnesium chloride. So write magnesium chloride. For the space will come beside chloride. And also means plus, and then they're saying hydrogen gas. Hydrogen gas. So you write hydrogen. Oh, look, this is not hydrogen. Sorry, guys. Hydrogen gas. So you see, once you write this weight equation like that, then you're good to go. You have seen. So from this weight equation, you will be able to write a balanced chemical equation. So now, as I said, a chemical equation is a short way of writing a chemical reaction using chemical symbols of elements in a chemical reaction. So we'll use a chemical symbol of magnesium, a chemical formula for hydrochloric acid, a chemical formula of magnesium chloride, and also chemical formula or the chemical symbol of hydrogen gas. Those are the one we'll use now. So here we'll write magnesium chloride. When you check on the periodic table, it is capital M. Now, magnesium is a metal. So if they said here, write a balanced chemical equation, include state symbols. State symbols, they mean you include symbols that indicate the state in which the substance is. So in this case, magnesium is a metal. So it is in which state of these three states, solid, liquid, and gas? It is in solid. So you put S here for solid. So we have written magnesium, Mg, S for solid, then you drop down the plus here. Then hydrochloric acid, here you have to memorize its chemical formula. It is always capital H, okay, capital L, and capital C and small letter L. Since it is an acid, in which state is it? It is in aqueous, where we write A and the Q like that. Then we maintain now the arrow. Then this magnesium chloride can be written as magnesium is capital M. Then chloride is like that. This one here, the chloride. Now this is not all. You need to drive the chemical formula for magnesium. So magnesium is written like this. Okay. So you need to know the valence of magnesium. The valence is the number of electrons that an atom loses or gains to become stable. So magnesium has got 12 electrons here, 12 down here. Here it is 24 if you check on the periodic table. So this 12 means that magnesium has 12 electrons. So these electrons sit in a magnesium atom in shells, as the first shell should have 2. So from 12 you get 2 you put in the first shell. So once the first shell has 2 electrons, it becomes stable. Then from 12 you remove 2, you remain with the 8 or 10 I mean. So then the 10 one, you get some 8 of them should go in the second shell. So this is the first shell, the second shell should have 8. So you from 10 you get 8 you put here. You remain with what? 2. So where does these 2 remaining go into the third shell? So since you have remained with 2, they will go here. Now the third shell is not stable by virtue of us giving it 2 electrons. It's supposed to have 8 or 18. So it has to, so it will not be stable. So magnesium can lose these 2 electrons to become stable. Therefore, this 2 becomes the valence for magnesium, which we put here as a power. Okay? So that's what you must understand. Okay? I did a video on my channel. You can check it out. Then chlorine as well. This chlorine here. If you go on the periodic table, you'll find that it is written as Cl. Okay, it is written as Cl. Let me look for the red marker. Red marker. So Cl, here it is 17, here 35.5. These numbers here work well in bonding, while these numbers here work well in Mohr concept. Okay, so power went, now it has come. I think you have seen some kind of brightness changing. Yeah, so it means also chlorine has got a number of electrons which is 17. Now, how do these electrons sit? In the first shell, it should get 2. So from 17, when you remove 2, you remain with what? You remain with 15. So 15, out of 15, some should go in the second shell. So from 15 you remove 8, 8 should go in the second shell. Then after you remove 8 from here, you remain with what? You remain with the 7. Then the 7 will go in the third shell here. They are the one remaining. Now this third shell is not full, having 7 electrons. It needs at least 18 or 8. So then for this shell having 7 electrons, for it to be full, it must gain 1 electron. So since magnesium gains 1 electron to make this to 8, then its valence becomes 1. So that's how these things operate. So when you do that, then now once you know, that's how we know the valence. Or we also use group in which the element is found. So then you say, okay, this is now magnesium, valence is 2, chlorine, the valence is 1. Then you swap, this one comes here, this one here. So this one will have magnesium with a 1 here, then the chloride with a 2 here. Equals, now 1 is never written, so it will remain magnesium like that, then chloride with a 2 here. Therefore, there will be a 2 here. So we'll write a 2 there like that. Then this will be in what state? Since it is magnesium that reacted with hydrochloric acid. So this one now will change, instead of being in solid, now magnesium and the hydrochloric acid will form magnesium chloride, which will be in aqueous state, which is a here like that. Then plus hydrogen gas, this one here, hydrogen gas, it is written like H2. Since it is a gas, we put G to mean that it is in the gassy state. So this is a chemical equation. Now we need to balance it. So we need to balance because it is not balanced as it is. Now, balancing, guys, involves ensuring that the number of atoms on the reactant side of the equation, chemical equation, must be equal to the number of atoms on the product side of the chemical equation. So here is what we do. You look at magnesium. How many magnesium atoms are here? 1. You go on the other side. How many are there? 1. So in the case of magnesium atom, they are balanced. Then once you do that, you shift to another atom of hydrogen here. You compare hydrogen atoms. How many are here? 1. Here, how many are there? 2. So since this side we have 2, this side we have 1, these are not balanced. You need to balance by ensuring that this side, which has less hydrogen atoms, should have also 2 hydrogen atoms. So how do you do? Don't put a number here, put it in front here to make them also 2. So now we have made the hydrogen atoms to be 2 by putting a 2 in front here, as it is here. Then you come to the chloride ion or the chlorine atom. Here the chlorine atom, because of these 2 here, it is also 2. Then you come here, chlorine atom, because of these 2 down here, it is 2. So you have seen here chlorine atom 2, here 2, so they are balanced. Therefore, if you check magnesium 1, hydrogen 2, hydrogen 2, chlorine 2, chlorine 2. So we have balanced the equation. So this is how we balance equations, guys. Now, let's do this other one. This other one, guys, is simple. B, they are saying we calculate the mass. B, calculate the mass of magnesium chloride formed when 6.0 grams of magnesium reacts with an excess of hydrochloric acid. So they're telling us that we need to calculate what? We need to know what we are calculating. Mass of magnesium chloride. Which one do they want? This one here. So in answering we need to use this equation. So we can rewrite it here. Magnesium. So here we can leave the state symbol because now we are using it. Then plus, you write like this, hydrochloric acid, then gives us magnesium chloride with a 2 there plus hydrogen gas. So then they told us to say, we calculate the mass of magnesium chloride. This one, the mass here, formed when 6.0 grams of magnesium reacts. So when you have 6 grams, so you have now magnesium 6 grams. So they have given you magnesium, then they are asking you to find the mass of magnesium chloride. That's how you connect it. They've given you magnesium, they're asking you to find the mass of magnesium chloride. Therefore, if you want, you can use mass to mass relationship where you say, here, they're saying calculate the mass of magnesium chloride formed when 6.0 grams. So say 6.0 grams of this magnesium reacts with the excess dilute hydrochloric acid. So when it reacts with that, they're saying find the mass here. So you can push it there and say, oh, we don't know here. You put in X. Right? As simple as that. So once you do that, you will use what we call mass to mass relationship. Where you need to know, in more concept, you use this number here. Magnesium has a number here, which is 24. Here also put it 24. Here chlorine has 35.5. So it is these numbers you say. So you say, okay, magnesium, since it is only alone, you get 24 here. Say 24 always goes with it. Here you add this plus this. So how do you add? You say 24 plus, because magnesium has 24 here alone, then you come to chlorine plus this. Chlorine has 35.5. Then times these two here, because chlorine has a 2 here. So you put 2 here because there are 2 atoms there. Then you say, okay, 24 now plus this one, 35 times 2, 35.5 times 2, it will give you 71. So you add this, 24 plus 71, you get 5, you get 9. So it is giving us what? 95. So here you put now 95. You say this is to that, this is to that. So you cross now multiplication. You say 24 times x, it will be 24x. Then you introduce equal sign. You say now 6.0 times 95. So let's make use of a cow. So let's do like 6.0 times 95. We are getting something like 570. 570. Because of this gram, let's push it here. Then what we're interested in is the x value, not the 24. So we divide this side by the 24. Also, we do the same by the 24. That one goes, you remain with x is equal to. So you divide. So same 570 divided by 24, we are getting 23.75. So we are getting 23.75. 3.75. Then we drop down the gram. Now, according to the rules of significant figure, since this value which we are given, it has one decimal place, we need to round off also this one so that we have one decimal place. So this one can now be like 23 point. We get the one put here to be 8 grams. So you say, therefore, 23.8 grams of magnesium chloride is produced. Okay, so that's how we find these questions here. They are very, very simple. So for those that are interested in vigorous online revisions for science, you can contact me on my online number 0977924175 so that you revise with me. You prepare yourself towards the coming exams for GCE and grade 12 internal. Okay, so you revise it is at a fee. I'm going to disclose the fee, which is constant. In this case, the fee is 120 per month. Both physics and chemistry 120 per month. Then you get to enter my online revisions. Okay, for now, guys, bye and see you in the next revision.